Okay, for these notes, we're going to be looking at one-step equations and two-step equations and inequalities. So we're going to look at solving the equations, solving the inequalities, and graphing the inequalities. So let's first get some initial information here. So whenever you solve an equation, your goal is going to be to get the variable by itself. Right, so what you want to end up with is just your variable, x or y, whatever the letter is, on one side of the equation, and just a number on the other side. You know, like x equals 5, y equals -2, something like that. So you want to get your variable by itself. And to do that, we're going to be using the opposite operation. So whatever's happening in the equation to the variable, you're going to do the opposite of that. So if it says x plus 5, you're going to be subtracting 5, and so on. Now, one other vocabulary term here is a coefficient. So a coefficient is a number in front of, which is multiplying, a variable. For example, 2x, 2 is the coefficient here. So that's a coefficient, C-O-E-F-F-I-C-I-E-N-T, coefficient. So a coefficient is a number in front of multiplying a variable. All right, let's get to some examples. So for one-step equations, first we have x minus 3 equals 9. So again, you want to look at your variable, see what's happening to it. Right here, it's being subtracted by 3. You're going to want to do the opposite, which is to add 3 to both sides. So remember, whatever you do to one side of an equation, you have to do to the other side of the equal sign. So the 3's cancel out here, and you've got x equals 12, and that is your answer. To make sure your answer is right, you can mentally plug it back in for your variable. And so if you think about that, 12 minus 3, that does equal 9. So you know that your answer is correct. Let's try number 2. It says 21 equals x plus 6. Well, x is being added by 6. So that's what's happening to the variable. We need to do the opposite. So no matter what side your variable's on, find it, see what's happening to it, and reverse it. So we got x plus 6. We're going to subtract 6 from both sides because that's the opposite operation. The -6 on this side cancels out that +6. So that's why we're doing the opposite operation, to sort of cancel it out on that side. 21 minus 6 is 15. And so that's our answer there. 15 equals x. Number 3, -7x equals 14. So this is a coefficient, right? -7 is a coefficient of x. And we know that that means it is multiplying that variable. So we're going to do the opposite. We're going to divide. So we need to divide both sides by -7. These will cancel here, and x is going to equal -2. Okay, number 4, x divided by 4 equals 7. The opposite of division is multiplication. So we're going to multiply both sides by 4. Those two will cancel here, leaving just x equals 28. 7 times 4 is 28. Number 5, we've got 3/4 x equals -9. Now, whenever you have a fraction for a coefficient, you can think of that in two ways. You know, on the one hand, you've got a coefficient of 3/4, which means x is being multiplied by 3/4. So you'll need to divide by 3/4 to solve the equation. And the way you divide by a fraction is by multiplying by the reciprocal. So you flip the fraction and multiply. You can also think of this as two operations, right? X is being multiplied by 3 and divided by 4. So to do the opposite there, you would multiply by 4 and divide by 3, which is the same thing as multiplying by the coefficient, or sorry, the reciprocal of the fraction. So in any case, what you're going to do is multiply by the flipped version of that fraction. So that's called the reciprocal. Flip the fraction and multiply. So these will cancel out on this side. And over here we have to do negative 9 times 4 and divided by 3. And that's how you do that. So negative 9 times 4 is negative 36. Divided by 3 is negative 12. Number 6 is very similar. We have 5/8 x equals 25. So we're going to multiply by the reciprocal, which is 8 over 5. These fractions cancel, and x equals 25 times 8 divided by 5. Well, 25 times 8 is 200, divided by 5 is 40. If those numbers are kind of too big for you to comfortably do in your head, you can do the opposite. You can do 25 divided by 5 first. That's 5 times 8 is 40. So you can do the opposite order. You can divide first and then multiply. So as long as you're multiplying by 8 and dividing by 5, it doesn't matter what order you do that in. So there you have the one-step equations. So whatever single operation is happening to the variable, do the opposite to solve. Now we're going to look at two-step equations. So here there are two things happening to the variable. For example, in number 1, x is being multiplied by 5, and then it's being added by 4. So what we're going to be doing is undoing those operations in the reverse order. So you're going to start with the addition problem and then get to the division problem. So this is sort of working in reverse order of operations. So for number 1, we're going to leave the 5x alone for now, and first we'll subtract 4. So these will cancel here. We'll have 5x equals 45. Now we can take care of the 5. So if we had tried to divide by 5 first, neither one of these numbers is divisible by 5, and we'd have a bunch of decimals. So what you'll want to do is worry about the addition and subtraction step first, and then take care of the multiplication step. Again, it's like working in reverse order of operations. So our final step here is to divide by 5, since x is being multiplied by 5. And x will equal 9. 45 divided by 5 is 9. And like I said before, you can always plug that in for the variable. If you plug in 9 right here, 9 times 5 is 45, plus 4 is 49. So we know our answer is correct. Let's go on to number 2. 7 equals 1/5 p minus 12. Again, we're going to leave that variable term alone for now. Let's take care of that minus 12 by adding 12. That's the opposite operation. So 1/5 p equals 19. Okay, now the opposite of 1/5. So remember before we flipped the fraction and multiplied. So the opposite of multiplying by 1/5 is multiplying by 5 over 1. So 1/5 times 5 is 1, those cancel out. We end up with p equals, and then 19 times 5 divided by 1, that is 95. 19 times 5 is 95. Now you might think to yourself, 95 sounds like a big number. All the other numbers I've been getting are fairly small. 28's the biggest so far. So if you're ever not sure of your answer, you should just plug it in for the variable and see if it works. So 95 times 1/5, that's the same thing as 95 divided by 5. That is 19, and 19 minus 12 is 7. So the answer is correct, but if you're ever not sure, you should check it. Okay, last one here. Again, leave this 3/7 x alone. We're going to subtract 4 from both sides. So 3/7 x equals -9. Be careful on the integer subtraction there. -5 minus 4 is -9. Now we can flip this fraction and multiply to cancel that out. So these cancel out. We multiply by 7/3. We get x equals, now -9 times 7 is -63. Divided by 3 is -21. But again, if you're ever not sure if those numbers are too big, divide first. -9 divided by 3 is -3 times 7 is negative 21. So it can be easier to divide first if you're more comfortable. And that is it for the equations. Now we're going to look at inequalities, which again, they work the same way. So the solving steps will be the same, but we'll also have to graph our answer, and that's where it gets a little tricky. So let's take a look. So we're going to solve inequalities just like we solve an equation, but remember, if you multiply or divide by a negative number when you're solving, you must flip the inequality symbol. So that's an important rule for remembering how to solve an inequality. And let's quickly go over the symbols and what they mean for the graph. So if your solution has x is greater than or x is greater than or equal to some number, let's say n for the number, this means you're going to shade to the right. Okay? The opposite would be if it's less than or equal to some number, you're going to shade to the left. Now, if you have one of these symbols, x is greater than or x is less than your number, you're going to use an open circle on your graph. And if you have one of the or equal to, so if you have the line on there, the or equal to line, then you're going to use a filled in circle. Okay, so the first two there, the direction, that's pretty straightforward. X is greater or x is greater than or equal to. We're shading in all the numbers that are bigger than that number, because that's what it says. X is greater than that number. Same for less than. We're shading all the numbers that are smaller. Now for the open and closed circle, what this equal to bar means is that the number we're graphing is part of the solution. X is greater than or equal to 5, or less than or equal to 5 means that 5 is included in the numbers that we're shading. When it says just greater than or less than, we're not including that number. So we leave it open circle, we leave the circle open to show that we're not shading in that number, but the solution starts there. And hopefully when we do some examples, you'll see what I mean there. So let's get to work. We got number one here. We have p minus 6 is greater than or equal to 3. This is a one-step inequality. Let's go ahead and add 6 to both sides. Cancel that out. So p is greater than or equal to 9. Now we do need to graph that. So let's go ahead and make a number line. And I'm just going to put 9 in the middle there. You could put other numbers on there if you want to. You know, like you could put 10 and 8 if you want to give it some context. Or some people like to just put 0 on whichever side 0 goes on. But I think we all know which direction 0 is from 9, so I don't mind. Just put 9 on there, that's fine. Now we have greater than or equal to, so we have the equal to bar on there. We're going to use a filled in circle, because 9 is part of our solution. P is greater than or equal to 9. And we're going to shade to the right. We're going to shade all the numbers greater than 9. Don't forget to include the arrow, because that shows that we are moving beyond our line. It goes on forever. Okay, looks like I'm missing a number 2, but we'll go ahead and go to number 3. We have negative 3/4 x less than or equal to 9. So we have to multiply by the reciprocal, which is negative 4/3. Should have given myself some more space there. It's okay. Times negative 4/3. These will cancel out. And x, now we didn't multiply by a negative, right? We multiplied by negative 4/3 when we solved. So we do need to flip that symbol. Don't forget that. Otherwise, your graph will go in the wrong direction. So 9 times negative 4 is negative 36 divided by 3. That's negative 12 for our solution. So we've got our number line here, centered at negative 12. And x is greater than or equal to negative 12. So we are going to fill in that circle, greater than or equal to. And it is going to shade to the right, all the numbers greater than negative 12. Now here's where you want to be careful if you're putting other numbers on the graph, because remember, negatives sort of work the opposite as positive numbers, so your number to the right would be negative 11. You know, we're going towards 0 to the right, so just be careful. If you're not sure, just put negative 12 on there and graph it, and don't worry about the other numbers. Okay, now let's look at some two-step inequalities. Remember, these work the same way as the two-step equation, so we're going to leave the variable term alone for now. Let's take care of this minus 3 by adding 3 to both sides. So we've got x over 7 is greater than 1. Negative 2 plus 3 is 1. Then the opposite of divide by 7 is multiply by 7. So we end up with x is greater than 7. 1 times 7 is 7. Let's graph it. So put 7 in the middle of our graph. X is greater than 7, so again, we're just going to use an open circle because 7 is not part of our solution. 7 is where the solution starts, but we want to shade all the numbers that are bigger than or greater than 7, which does not include 7. 7.1, 7.00001, 1,000. These are all numbers bigger than 7, but we don't want to actually graph 7, so we leave the circle open to show that. All right, last one here. We've got negative 1 is less than 8p plus 15. Again, find your variable, even if it's on the right-hand side. Find your variable. We're going to do the opposite operations. Leave the 8p alone for now. Let's take care of that plus 15 by subtracting 15. So negative 1 minus 16 is negative 1 minus 15 is negative 16. We still have less than 8p. Now we can divide. We're going to divide by 8. So we end up with, and the way it's written here would be negative 2 less than p. But you want to be careful because with inequalities, it's all based on the variable. So you want to read this inequality from the perspective of the variable. So it might help to have the variable always on the left-hand side, which means we need to rotate this whole thing around. So that would be p is greater than negative 2. Just be careful when you do that, because make sure if your symbol is open to the p here, it needs to be open to it here. We're just mirror imaging, rotating that whole thing around so that when we read it, we're reading it from the perspective of the variable. So let's graph that. Because if we just rotated and did this, if we just switched the p and the 2, it would change the direction of our graph. So make sure you rotate the whole thing. Okay, so negative 2 in the middle. We're going to graph this open circle because it's just greater than. Open circle here, and we're shading again greater than, so shade to the right. And that is our graph. So here's our solution and the graph there, solution and the graph here. And there you have 1 and 2 step inequalities and 1 and 2 step equations. Feel free to review